Hello, students. Good evening, all of you. Welcome back. So, if you remember yesterday, what we did was variable separable method. Let me give you a quick recap. What we were doing. We were doing solution of differential equations. In that, we have three ways. First is variable separable. The second, which we are going to do today. So today's agenda or today's topic is homogeneous differential equations. And then the third, which is the last, which is linear differential equation. And after that, we'll be doing applications of differential equation. So before moving forward, let you tell me if my voice is clear or not. If it's clear and all is good, give me a thumbs up. We can move forward. Okay, super. Chalo. Let's see what are homogeneous differential equations. Should we wait for others to join, or these are the students? Only three of them have joined. Should we wait or should we start? Is there any reason others are not coming? Or vacation mood में है सब? Okay, we'll start. Chalo. So, what are homogeneous differential equations? Acha, before diving into homogeneous differential equation, let us first see what are homogeneous equations. I know that you have studied homogeneous equation in the chapter functions, but you might have forgotten. So let's start with what are homogeneous equations. Yeah. So what are homogeneous equations? As you can see, what is the definition? A function is said to be homogeneous of the order n if we substitute kx in place of x and ky in place of y, and all the powers of k comes outside the function. All the powers of k comes outside the function, then it is an homogeneous function. Let me repeat myself. If in a function, if I put kx in place of x and ky in place of y, and all the powers of k come outside this, all the powers of k comes outside, then the function is homogeneous with degree n. Let us see some examples. This one. So it says that show that the function is a homogeneous function of degree 3. So what do we do to check homogeneous? We replace x by kx and y by ky. So what my function will become? I will get 4 into kx square into ky, correct? Plus 2 into kx into ky square. As you can see, I'll get 4k cube x square y plus 2k cube x y square. So as you can see, I can take k cube common, and what I'll be left with? 4x square y plus 2xy square. What does this mean? That k raised to the power 3 into I got the original function back, f of x comma y. That means that it is f of x comma y is a homogeneous function with degree 3. Got it? One more thing, property of homogeneous function is here, key. I can take x common or y common. I can take x raised to the power n common or y raised to the power n common. And after taking x raised to the power n common, I get a function g of y by x. That is a function in terms of y upon x. Then too, my function is always a homogeneous function. Let's check this in this example. Suppose from this, I took x cube common. So what I'll get is, if I took x cube common, that means I'll get x cube into 4y upon x plus 2y upon x the whole square. Now, as you can see, this function here is a function of y upon x. This y upon x is a function of y upon x. So same thing, it is same thing, just a different way of saying. Instead, do this method, that is replace x by kx, y by ky, or just take x power common such that the remaining inside function is a function of y upon x. Got it? Chalo. Now let's see finally what are homogeneous differential equation. So, acha, before this, we saw this, right? We just solved this. 4x square y square is the homogeneous function of degree 3. Chalo. So here, what are homogeneous differential equation? So let me tell you, in yesterday's class, I told you ki always make a habit to write the equation in this form. That is dy by dx on one side, all the other terms on the other side. So if I write the differential equation in such a way that dy by dx is f of x comma y upon g of x comma y, then this differential equation will be homogeneous only if f of x comma y and g of x comma y both, f of x comma y and g of x comma y both are homogeneous functions of same degree. That means f and g should be homogeneous, but they should be of the same degree. Then the differential equation will be a homogeneous differential equation. Chalo. Here you can see an example. See here. One of the ways to check again homogeneous equation is in the numerator, you see this term and this term. There are two terms. The degree of this term is 2. The degree of this term is also 2. That means the degree of all the function in the numerator is 2. Let's check denominator. Denominator, again we have two terms. The degree of this is 2. Here, two functions are multiplying. So the degree will be 1 of x plus 1 of y, which will be 2. Therefore, the whole degree is also 2. That means the numerator, this, which is my f of x comma y, is a function of degree 2. The denominator, which is g of x comma y, is also a function of degree 2. And if both of them are functions of same degree, that means my differential equation is a homogeneous differential equations. I hope you are clear. If it is clear, give me a thumbs up, or you can say or ask if you have any doubts till here. Then we'll move forward. Chalo. Clear everything until here? All good? Come on, guys. All good till here? Got it? Okay, super. Chalo. Now, let us see how to solve homogeneous equation. If you remember, yesterday I told you, finally after all simplification, we'll be landing at the same point, which is variable separable. That is the basis of all the methods of solution of differential equation. We'll be landing on the same base point, which is variable separable. So, what or how to solve the homogeneous differential equation? So, here we saw this is a homogeneous differential equation, means this will be a function of y by x. So, what do we do is the main thing is to substitute y upon x equal to v or y equal to vx. This is the main thing. That is to substitute y upon x equals to v or y equals to vx. After substitution, what we generally do, we differentiate. It is a common step. we'll study from integration. So if I differentiate with respect to x, here I'll use chain rule. And then I substitute this value in the original equation here. So I substitute this value in this equation, and my equation will now become variable separable. You can see here. If I substitute this here, my equation will look like this, which is obviously a variable separable, which is the ending. Now, let's start with the questions. You'll be more clear here. Got it? Chalo. Yeah. Okay. So this you can see. First, let me check if it is a homogeneous or not. So we can clearly say it is homogeneous because numerator has degree 1, denominator also has degree 1. That means it is a homogeneous differential equation. Without skipping any steps, let's do step by step. So what was the first thing? First thing was substitute y is equals to v into x. After that, we differentiate with respect to x. So I'll get dy by dx equals to, here we'll use product rule, v into derivative of x plus x into derivative of v. So I'll get dy upon dx equal to v plus x dv by dx. Got it? This is equation number 1. Now, what my question will become? My question will become dy over dx after substitution is equals to x minus vx upon x plus vx. We can take x common from numerator and denominator and it will get cancelled. So I'll get 1 minus v upon 1 plus v. Let's mark this as equation 2. Now substitute equation 1 in equation 2. What I'll get? On the left hand side, I'll get v plus x dv by dx is equal to, what is on the right hand side? It is 1 minus v upon 1 plus v. Let's simplify. So x dv over dx will be equals to 1 minus v upon 1 plus v minus v. Correct? So if I take LCM, I'll get x dv over dx is equals to 1 minus v minus v square upon 1 plus v. That is, I got 1 minus 2v minus v square upon 1 plus v. That is x dv over dx. Got it? So this is a variable separable form. We can easily separate. We just have to cross multiply. So I got v plus 1 upon, right now I hope I didn't make any mistakes, minus v square. Yeah, v plus 1 upon, if I take minus common, I'll get v square plus 2v minus 1 dv. I'll like shift minus to the other side, minus dx upon x. Now what is left? To integrate both the sides. So if I integrate both the sides, right hand side ka integration is very simple. What should we do on the left hand side? We'll multiply and divide with 2. So on the left hand side, I'll multiply and divide with 2. So what I'll get is, I'll get 1 by 2 integration of 2v plus 2 upon v square plus 2v minus 1 dv is equals to minus integration of dx over x. Now, interesting thing, you can see denominator is f of x and numerator is f dash of x. So what is integration of f dash of x upon f of x? If you remember, it is ln f of x, ln v square plus 2v minus 1 is equals to minus ln x plus c. Now, if you remember, I told you that in such cases, when we have ln, we tend not to leave the answer in terms of log. What we do, we'll leave the answer after simplifying the log. Anyways, we have to resubstitute the value of v. Agar y equals to vx, so v equals to y upon x. So if I cross multiply, let me write this c. I can write this arbitrary constant c as ln c, right? So, I'll cross multiply and then write. So ln y square by x square plus 2y by x minus 1 is equals to, if 2 cross multiplies, I'll get, I'll take everything on left hand side. So if I take ln x on left hand side, I'll get plus 2 ln x. That will become ln x square equals to ln c. Now on left hand side, I can use the property of log. These two will get multiplied. So I'll get y square plus 2xy minus x square is equals to ln c. I can take anti-log on both sides. So my final answer will be y square plus 2xy minus x square is equals to c. This is my answer. I hope it is clear. Got it? If it is clear till here, please, you can give me a thumbs up or you can say understood, or if you have any doubt, you can ask. Clear till here? Chalo. Guys, clear till here? Give me a thumbs up if it's clear, or you have you any doubt? No doubt, then we can move forward. Okay, super. Chalo. So let's see next question. Yeah. Solve. Okay, super. Yes, sir. Good. Chalo. This one. Now, this is not exactly in the format. So, if you remember, I told you to always make a habit to write a differential equation in dy by dx equals to something. So, if I write dy by dx, that is basically I'll cross multiply. What I'll get is x square plus y square upon 2xy. You can check it for yourself. The degree of numerator is 2. Degree of denominator is also 2, because 1 plus 1 na, दोनों का degree 1 1 hai, and they are getting multiplied. This is 2 and 2. That means this is a homogeneous differential equation. What we do in such case, we substitute y equals to vx. If I substitute y equals to vx, now I differentiate. So I'll get dy over dx is equals to v plus x dv by dx. This is equation number 1. Now what will my equation become? If I substitute here, so I'll get x square plus v square x square upon 2x square v. Right, y की जगह पे vx to 2vx square. I can take x square common from numerator and I can cancel it out with denominator. So I'll get 1 plus v square upon 2v. Now let's mark this equation 2. Substitute 1 in 2. Substitute 1 in 2. So what I'll be left with is v plus x dv by dx is equals to 1 plus v square upon 2v. So let's simplify. So if I take v on the right hand side, I'll get x dv by dx is equals to 1 plus v square upon 2v minus v. So if I take LCM, I'll get 1 minus v square upon 2v. Correct? X dv by dx. Now let's just cross multiply. It is variable separable. So I'll get 2v upon 1 minus v square dv is equals to dx over x. Let's integrate on both the sides. Correct? Now, just have to adjust. So I'll multiply with minus on both the sides. Why? Because now you can easily see that this left hand side is of the form f dash of x upon f of x. So if what is the integration of such form? We did it just now in the last question itself. The integration is ln mod of f of x, so ln 1 minus v square is equals to minus ln x plus ln c. Instead of c, I am writing ln c. So if I take ln x on right hand side, I'll get ln, what is v square? 1 minus y square upon x square plus ln x plus, sorry, is equals to ln c. If I use a property, what I'll get? I'll get ln x minus y square upon x is equals to ln c. Taking antilog on both sides and LCM also, so I'll get x square minus y square upon x is equals to c. That means x square minus y square is equals to cx is my answer. As I've told you yesterday many times, today also I'm telling you, if we ever see log, we need to simplify, because in option there will be the simplified form. If you understood this question again, give me a thumbs up so we can proceed further. Got it? Chalo guys, come on. All good till here? If you have any doubt, please ask. Okay, very good. Day one, super. Chalo. Devan, give me a thumbs up. So let's proceed. So let's move on to the next question. This one. This is a good question. Now, do you remember there were two substitutions, if you remember, in the homogeneous differential equation, how to solve them? If you remember, there were two substitutions. One was y upon x equal to v, or as we say, y equal to vx. The second one was x equal to vy, or x upon y equals to v. So here, as you can see, there are terms. One second. There are terms where we can see x upon y. So it is better to use the substitution x upon y equals to v instead of y upon x equals to v. So this means that x will be equals to vy. Got it? So what will now we get? Now if I differentiate with respect to y. See, please understand, when we use y equal to vx, the dependent variable is y, independent variable is x. That means we get dy over dx. I'll make, I'll write here. Do we have space? Okay, I'll try writing it here. When we put y equals to vx, implies my equation will be dy over dx. But when I use x equals to vy, then my dependent and independent variables are interchanged. That means x equal to vy implies my equation will now be dx over dy. And if I want the equation dx over dy, then I need to differentiate with respect to y. Then only I get dx over dy. So if I differentiate with respect to y, I'll get dx over dy is equals to v into derivative of y plus y into derivative of v. So this time y is not substituted, x is substituted. Let's mark it equation 1. Acha, we will simplify the given question. If we simplify the given question, I'll get 1 plus e raised to x by y dx plus e raised to, we want dy dx by dy, right? So I'll divide by dy, so I'll get dx by dy after cross multiplying e raised to x by y, 1 minus x by y equals to 0. Let this be equation number 2. Substitute 1 and 2. What we'll get? We'll get 1 plus e raised to v. Right, na? Haan. Acha. Let us simplify it more. We'll directly write dx by dy. I hope it is fine. So from here, dx over dy, it will be more simpler like this. So dx over dy will be equals to minus e raised to x by y into 1 minus x by y. I took it on the right hand side upon 1 plus e raised to x by y. Mark it as equation 2 this. And substitute 1 and 2. Cancel out this. Yeah, substitute 1 and 2. So now my equation will become v plus y dv by dy is equals to minus e raised to v into 1 minus v upon 1 plus e raised to v. Let us simplify as we do every time. So I'll get y dv over dy is equals to minus e raised to v plus v into e raised to v upon 1 plus e raised to v minus v. So if I take LCM, I'll get minus v, so this will get cancelled. So I get minus e raised to v minus v upon e raised to v plus 1. This will be y dv over dy. Now just cross multiply and use variable separable. So I'll get e raised to v plus 1 upon e raised to v plus v dv. I took minus common from this side and gave it this side. So minus dy upon y. Now what is left? It is left to integrate both the sides. As you can see again, what is this? This is f of x and this is f dash of x. So that means what is the integration of this? Is it ln e raised to v plus v, correct? Is equals to minus ln y plus ln c. Same simplification will do. So I'll get ln e raised to x by y plus x by y, correct? Plus ln y is equals to ln c. So on the left hand side, I can use the property of log. I'll get ln y e raised to x by y plus x is equals to ln c. I can take anti-log on both the sides. So my final answer will be y e raised to x upon y plus x is equals to c. This is my answer. Sometimes it is easier to substitute x by y as v. If you want, if you are really curious or you must have tried this, you can use the substitution y equals to vx. You can use this substitution and try at home. You will get the same answer, but it will be more lengthier. So if it's more lengthier, avoid it. We'll use this. So if we see x by y, we use the substitution this. Got it? The next question. Solve. Again, what we have our aim to get dy over dx. So what will be dy over dx? It will be y plus x cos square y by x upon x, right? So if I split the denominator, I'll get y by x plus x and x will get cancelled from here, cos square y by x. This is my dy over dx. Let me mark this as equation number 1. What is substitution? It is not no x by y, it is y by x only, right? So our general substitution y equals to vx. This means dy over dx will be equals to v plus x dv by dx. This is equation number 2. Substitute this here. So I'll get, acha, wait 1 second. This equation will now become, v plus cos square v, correct? Now substitute it here. So what we get is, we'll be getting v plus cos square v is equal to v plus x dv by dx. This is very simple. V and v will get cancelled. So we'll be left with cos square v is equals to x dv over dx. Now I'll cross multiply. So I'll get dx by x is equals to dv by cos square x. What is cos square x? 1 upon cos square x. I can write it as sec square x. So sec square v dv. Simple. Both of the integration are very simple. So we'll simply integrate both the sides. So if I integrate both the sides, what I'll get? I'll get ln x is equals to tan v plus ln c. Right? So if I take on left, ln x by c by using the property of log, minus हो जाएगा ना, is equals to tan y by x. So what is my answer? If I take anti-log, I'll get x is equals to c into e raised to the power tan y by x. This is my answer. I hope you got it. Correct? If you got it, please give me a thumbs up so we can proceed further. Completed. Okay, super, super. चलो. बाकी लोग क्या कर रहे हैं? Only Devan is solving. Others are understanding. You can give me a thumbs up at least. चलो. बाकी लोग Swati, Niranjan. अच्छा, only you 3 are there. You didn't tell me. I asked ki others. Where are others? Niranjan said, okay, superb. You don't know where are others? Okay, no problem. Chalo. Let's move on to the next. Next question is this. Equations reducible to homogeneous form. Now, if you notice the pattern, what is the pattern? Till now, we have 3 methods: variable separable, homogeneous, linear. Now, if you remember variable separable, how we did it as, we did variable separable, then equations reducible to variable separable. Now, same is with homogeneous. Homogeneous, equation reducible to homogeneous. And same will be with linear differential equations, equation reducible to linear differential. So, the same pattern is there. Now we are seeing equation reducible to homogeneous form. Now let me tell you, I personally do not expect, or according to the past year papers of JEE mains, personally I have not seen this type of question, which is equation reducible for homogeneous. Why? Because these are generally lengthy. They may ask in some paper. Anyways, they have also asked, but these are not their favorite questions. What is meant by favorite? These are very lengthy sums. You'll get a hang of what I meant by lengthy sums. But let us first see how we can reduce the differential equation to homogeneous form. As you know, I always write the equation in this form. This is basically linear upon linear form, right? Obviously, this is not homogeneous because this is a constant term. These both are constant terms. And constant terms have degree 0. Terms ax plus by degree 1. So this is not a homogeneous because degrees are not matching. So what do we do in these types of sum? We make them homogeneous. How do we make them homogeneous? We make them homogeneous by substitution, by this substitution. What is the substitution? X equal to x plus h, y equal to y plus k. You might have seen this substitution somewhere. Let me remind you. You might have seen this substitution in a shift of origin. याद आया कुछ? So basically here we are doing the same. We are basically shifting the origin if we consider the coordinate geometry part. But let's not go into that. The substitution is same as shift of origin. So here h and k are constants. H and k are constants. Correct? So if I differentiate with respect to x, so I'll get dx equals to dx and dy equals to dy. I hope it is clear. So after this substitution, my equation will now look like, equation was like this, now it is like this. Now see this part, there is again this part, right? This red highlighted part. 1 second. Yeah. This red highlighted part again have degree 1 because it's a constant term. H and K are constant and A, B, C are also constant. So these both terms have degrees 0 and the remaining these terms have degree 1. So what do we do is to make it homogeneous, we substitute or we write these terms as 0. Then my equation will be reduced to this. Now you can see numerator is degree 1, denominator also is degree 1. That means there is a homogeneous differential equation. Now, how do we make these terms 0? How do we make these terms 0? We need to have some value for h and k. See, the equation was given like this. That means we know the value of a, b, c and a1, b1, c1. We don't know the value of h and k because we substituted it. So by solving this equation, we can write it here. Solve these to get h and k. We'll solve this equation simultaneously so as to get the value of h and k. Once we get the value of h and k, we can simply substitute and we can write our answers. Got it? So let's look at the question. Acha, now you see further, this is a homogeneous equation. How we solve the homogeneous equation? By substituting y equals to vx. Now, every time the small y is given, small y or small x se kya ho gaya? Capital Y and capital X. And finally, we'll replace x by x minus h or resubstitute basically. So you can see it is a very long procedure. That's why many times it is not asked, but we have it in portion. That's why we have to study. So let's see one example. Chalo, it will be very clear in this example. Solve this equation. Now we can see it is linear upon linear. It is already in that form. So if we see this type of equation, that is linear upon linear. What is our substitution? Our substitution is substitute capital X equals to, is our substitution wrong? Yes, obviously. We have interchanged the variable. Sorry. Substitute small x equals to x plus h and small y equals to y plus k. Got it? So if I differentiate it, I'll get dx equals to dx because h ka derivative is 0 and dy is equals to dy. So my equation will reduce to dy over dx, capital letters, is equals to, if I substitute it here, I'll get 6 into x plus h plus 5 into y plus k plus 7 upon 2 into x plus h plus 18 into y plus k plus 7. So if I simplify, I'll get 6x. Let's group the x terms together. 6x plus 5y. बराबर ना? Plus, let's group the constants together. 6h plus 5k plus 7 upon, I'll get 2x plus 18y plus 18k plus, wait, okay, here it is minus 14. We made a mistake. You also did not pay attention. So here it is minus 14, right? I hope we not have 6, 5, 7, 2, 18, minus 14. Yeah, minus 14. Now, what do we do to make this homogeneous? We have to make these both terms 0. So if I make these both terms 0, that is 6h plus 5k plus 7 equals to 0 and 2h plus 18k minus 14 equals to 0. Now, I am giving you some time. Let me give you 2 minutes so that you can tell me the values of h and k after solving them simultaneously. Come on, guys. I would like you tell me the values of h and k because it's a very simple simultaneous equation. You have been doing this from school level. Till then, I'll drink some water. If you want, you might also drink some water. But after that, please solve this and tell me the values of h and k. Got it? Chalo, the time starts now. 2 minutes, guys. Fatafat. Chalo, I'm back. I hope you have made some progress. Devan, Niranjan, and Swati. Come on, let's see what answer you guys get. Oh, you already got an answer. H is minus 2, K is 1. Very fast. Superb. You have a nice speed. So speed will not be an issue for you in JEE mains. Correct? Chalo, no problem. I'm waiting for other two. I'll give you 1 more minute, then I'll solve it myself. Chalo, come on, guys. No progress by other two? Okay, I'll start. I guess I multiply this with 3, right? Then I can cancel out h. So I'll get 6h plus 5k is equals to minus 7. If I multiply this with 3, I get 6h. 18 threes are 54. I hope my tables are good. Is equals to 14 threes are 42. And now I'll subtract. This will get cancelled. I'll get 49k is equals to 49. That means k is 1. Superb. K is 1. Now substitute here. So I'll get 6h plus 5 plus 7 equals to 0. So 6h equals to minus 12. H is minus 2. Very good. Super. So h is minus 2, k is 1. So now my differential equation will become, oh, 1 second. Yeah, h is minus 2, k is 1. I have made this here to just cross check our answers. Chalo. H is minus 2, k is 1. So my differential equation will become dy over dx is equals to, what was it? Yeah, 6x plus 5y, 2x plus 18y. 6x plus 5y upon 2x plus 18y. So now it is a homogeneous. What will substitute? Y equals to Vx. All letters are capital. That means dy over dx will be equals to V plus x dv over dx. So my equation will become 6x plus 5vx upon 2x plus 18vx. I can take x common, I can cancel it. So 6 plus 5v upon 2 plus 18v. Now substitute this here. So mark it as equation. Then I'll substitute 1 and 2. So if I substitute 1 into, I'll get 6 plus 5v upon 2 plus 18v is equals to v plus x dv over dx. If I rearrange or if I simplify it, I'll get x dv by dx is equals to 6 plus 5v upon 2 plus 18v minus v. So this will be minus 2v. So 6 plus 3v right now minus 2v minus 18v square upon 2 plus 18v is equals to x dv by dx. If I cross multiply, now it's simple, it is variable separable. So I'll get 2 plus 18v upon 6 plus 3v minus 18v square dv is equals to dx over x. Now I just integrate both the sides. Now, how do we integrate this? The first we can take 2 and 3 common, right? So let us simplify it. So if I take 2 and 3 common, what I will be left with? 2 by 3 बाहर आ जाएगा ना? So 2 by 3 integration of 1 plus 9v upon minus v common ले लेते हैं. So I'll get 6v square minus v. Right? So 6v square minus v minus 2 dv is equals to integration of dx over x. Now, how do we integrate this? Huh? How do we integrate this? Again, we have to use this linear upon quadratic. Acha, denominator is factorizing kya? 4 3s are 12. Minus 4 plus 3. We can factorize the denominator. So 6v square minus v minus 2 can be written as 6v square minus 4v plus 3v minus 2. So I'll take 2v common, 3v minus 2 plus 3v minus 2. So I can write it as 3v minus 2 into 2v plus 1. So now I'll consider this separately and I'll integrate it. Right? We can use partial fractions. Yeah, we got the same result, right? So no need of this. What we got? 1 plus 9v, 1 plus 9v upon 3v minus 2, 2v plus 1. 3v minus 2 into 2v plus 1 is equals to a upon 3v minus 2 plus b upon 2v plus 1. So can we adjust it directly? 6 is only 3. So I'll get 6 plus this. Oh, there is no need to do partial fractions. See guys, you can adjust it directly. I mean, I just now saw it. I just now adjusted it, but we can also use partial. So what we did is, see, I'll multiply this with 3. So I'll get 3 2v plus 1, right? 6v plus 3v minus 2 upon 3v minus 2 into 2v plus 1. 6, 7, 8, 9v, 3 minus 2, 1. See, this is exactly the same. I can adjust the numerator like this. If you can see. Check this once. Open this bracket numerator. I get 1 plus 9v. So that means basically if you use partial fractions, we will get the same thing, but this just increases the speed. So if I split now, I'll get 3 upon 2v, 3 upon 3v minus 2 plus 1 upon 2v plus 1, right? And now I have to integrate this. So my final answer or my equation will now become 2 by minus 3 यहाँ पे था, right? So minus 2 by 3 integration of 3 upon 3v minus 2 plus 1 upon 2v plus 1 dv is equals to integration of dx over x, right? Dx over x is So now all these integrations are very simple. All are log format. So I'll get into 3 ln 3v minus 2. Don't forget upon 3. V का coefficient है ना, 3 and 3 will get cancelled plus ln 2v plus 1 upon 2 is equals to ln x plus ln c. So here what we can do, okay, how we can simplify it? We'll have to take LCM, right? So we'll get minus 4 by 3 into ln 2 ln 3v minus 2. So I can use the property of log and substitute this to up rear, right? Plus ln 2v plus 1 is equal to ln x plus ln c. So this minus 4 by 3, I'll minus 3 by 4 here, and this will remain the same. This is the arbitrary constant. So that means my LHS will now be ln 3y by x minus 2 the whole square into 2y by x plus 1 is equals to ln x raised to the power minus 3 by 4 into c. I can cancel out ln from both the sides. So, and I can take LCM. So I'll get 3y minus 2x the whole square into 2y plus x the whole square upon x cube is equals to c into x raised to minus 3 by 4. So if I cross multiply, so I'll get my final answer 3y minus 2x the whole square into 2y plus x the whole square is equal to c. The power will get added. 3 minus 3 by 4, 12 minus 3 by 4, 9 by 4 I'll get. X raised to the power 9 by 4. This is my final answer. Now I hope you understood Why? These types of question will not come. Again, this is not my final answer. Why? Because I have to resubstitute capital X and Y. That I am not doing. I am leaving up to you because I have to resubstitute capital X and Y from here. Got it? From here I have to resubstitute. So, finally, very lengthy sum is completed. Merely 99, yeah, it's horrible. 99%, very calculative. It's not horrible, it is very simple question, but it is just very calculative. So 99%, this question will not come, so I will not recommend it to like practice this question. I guess one question is enough. So we'll end our session here. And we'll now meet today is Friday, right? Saturday, Sunday. Huh? So we'll now directly meet Monday, which will be doing the next part, which is linear differential equations. So how we'll do proceed same linear differential equation reducible to linear. And then we'll do the last part, which is application. So 2 days you have, not I guess holiday from these lectures, online lectures. Okay. Chalo, bye bye. Take care everyone. Thank you all.